Hello, this is Chris Fuqua, and we're going to now cover some extra practice problems over solving non-linear systems of equations. So this is just adding to what we did in class on Tuesday. So let's start with this problem here. We have 2x squared plus y squared equals 18, and xy is equal to 4. So these are a little more exciting than the ones we did in class. This particular problem right here, or this particular equation right here, is called an ellipse. And this equation here is represented of a rational equation. So there is actually a possibility of 4 solutions, just like it would be if there was a circle. So just a quick glance at a possibility. Here's a rational equation, and then here's an ellipse. You can see a possibility of 4 solutions. Now, of course, the ellipse could be orientated different either horizontally or vertically. This is a horizontal orientation, but I am thinking by looking at this equation that it's going to be a vertical ellipse. So it may look more like this. Or something like that. Well, that part right there is a little off. Something like that. All right, anyway, we can see here that elimination will not help us in this way. So we're going to use substitution. So I'm going to take this equation and I'm going to solve for y. So if I solve for y here, I get y is equal to 4 divided by x. And now I'm going to substitute y equals 4 over x into equation 2x squared plus y squared equals 18 for y. So if I substitute that in, I get 2x squared plus 4 over x squared is equal to 18. And then simplifying that, I get 2x squared plus 16 over x squared is equal to 18. And now we have a rational equation we need to solve. So in order to solve a rational equation, you determine the LCD. The LCD here is x squared, which makes the restriction on x cannot equal 0. So I'm going to multiply the equation, or both sides of the equation, by x squared in order to clear the fraction. So now we're here. And distributing the x squared, we get what we want, which is the fractions to clear. X squared times 2x squared is 2x to the 4th. X squared times 16 over x squared is just 16. And x squared times 18 is 18x squared. Now I can see that this has a quadratic form. So I'm going to set it equal to 0 and see if I can factor it as if it was a quadratic. So I subtract 18x squared from both sides. I see that I have a common factor of 2. So I'm going to divide each term by 2, and I can do that because it's equal to 0. So that results in x to the 4th minus 9x squared plus 8 is equal to 0. and then factoring x to the fourth minus 9x squared plus 8. That will factor into x squared minus 8, x squared minus 1, because two numbers that multiply to get positive 8 and add to get negative 9 would be negative 8 and negative 1. And now I have two equations to solve. I need to solve x squared minus 8 set equal to 0, and I need to solve x squared minus 1 equal to 0. For this equation, we see that x squared is equal to 8, and square rooting both sides, I get the absolute value of x is equal to plus or minus, or excuse me, no, not plus or minus yet. The absolute value of x is equal to 2 root 2. Therefore, x is equal to plus or minus 2 root 2. Solving this equation for x, I can once again isolate the x squared by adding 1 to both sides. Apply the square root to both sides as the inverse, and I get the absolute value of x is equal to the square root of 1, which is 1. Therefore, x is equal to plus or minus 1. And as we know, when you're solving a system, it's an ordered pair in this case. So I need to determine what x is or what y is equal to when x is equal to plus or minus 2 and when x is equal to plus or minus 1. So if I remember back at the top, I have one of the equations already set equal to y. So I'm just going to substitute in the plus or minus 2 root 2. So y equals 4 over plus or minus 2 root 2. And then simplify that to y equals plus or minus 2 over root 2. Rationalizing the denominator, multiplying the top and the bottom by root 2, and I get plus or minus 2 root 2 over 2, which simplifies to plus or minus root 2. So I have two solutions. X is 2 root 2 plus or minus, and y is square root of 2. And now I do the same thing for x is equal to plus or minus 1. So when x is equal to plus or minus 1, I get 4 over plus or minus 1, which equals plus or minus 4. Therefore, my other two solutions would be plus or minus 1, comma, plus or minus 4. So that's a total of 4 solutions. So let's take a quick look at this scenario graphically. And I see that one of my solutions is negative 2.828, comma, negative 1.414. One of my solutions is negative 1, comma, negative 4. The other solution is 1, comma, 4. And then finally 2.828, comma, 1.414. All right, let's move on to number 2. In this situation here, I see that I have a cubic function. So this represents a cubic function. Well, let's call it a cubic equation for now. instead of a function, it is going to look like a function. It is a function if you set it equal to y, but this is a cubic equation. And 2x squared minus y equals 0 is a quadratic equation. So I basically have a cubic function and a parabola, or a cube function and a parabola. So this one is much easier than the previous example because we can immediately perform elimination. If we add these two equations together, it will eliminate the y value, the y variable. So if I add these two equations together, x cubed plus 2x squared is x cubed plus 2x squared. The y's cancel, and 0 plus 0 is 0. So now I can solve this equation by factoring. Both of these terms have a common factor of x squared. So that leaves us with x squared times x plus 2. And by the zero product property, x squared is equal to 0, or x plus 2 is equal to 0. And if x squared equals 0, then that means x is equal to 0, because I square root both sides. But 0, x equals 0, has multiplicity 2. So that tells us that we're going to have to, or that tells us that it's going to just touch the graph instead of intersecting it, or instead of crossing the graph. Or x is equal to -2. So if x equals 0, we need to determine what y is equal to. So we're going to substitute it into equation 1 here. So 0 cubed plus y equals 0. Therefore, y is equal to 0. So one of our solutions is 0, 0. But remember, this is multiplicity, so we'll have a touch of the graph. And then when x is equal to -2, -2 cubed plus y equals 0, which means -8 plus y equals 0. Therefore, y is equal to 8. So our other solution is -2, 8. And now let's take a look at that on the graph just to check our work. So one of the equations is, what was it? There we go. X cubed plus y equals 0, and 2x squared minus y equals 0. Maximize that, and we see that we have a solution at -2, 8 and at 0, 0, showing you that it just touches there, so it has multiplicity 2. All right, let's move on. The next example is a graph that represents an ellipse again, an ellipse. and a line. So in this particular case, a situation could be this. It could be this. Or even this entirely. It looks like the slope is negative, so just picture a negative slope here, negative slope here. Well, anyway, getting out of, let me just redraw it, just so there's no confusion. So we have an ellipse, possibly like this, an ellipse like this, an ellipse maybe like that. So we can have 1, 2, or 0 solutions. All right, so x squared plus 4y squared equals 2, and x plus 2y equals 6. This would be a system that substitution would work great. If I take this equation and I solve for x is equal to 6 minus 2y. And now I take 6 minus 2y and substitute it into the other equation for x. So that's 6 minus 2y squared plus 4y squared is equal to 20. And now simplifying the equation, I need to multiply 6 minus 2y times 6 minus 2y, which will give us 36 minus 24y plus 4y squared, and then plus 4y squared equals 20. So this is a quadratic equation, so let's simplify the result. And so adding like terms here, we get 8y squared minus 24y plus 36 equals 20. Subtracting the 20 from both sides, 8y squared minus 24y plus 16 equals 0. And we can simplify this equation even more by dividing every term by 8. So that gives us y squared minus 3y plus 2 is equal to 0. I'm going to go up here because we're running out of room. So if I factor y squared minus 3y plus 2, that factors into y minus 2 times y minus 1. Therefore, y minus 2 equals 0, or y minus 1 equals 0. So y is equal to 2, or y is equal to 1. And now I substitute back in, because I already have this equation solved for x. So x is equal to 6 minus 2 times 2. Therefore, x is equal to 2. And x is equal to 6 minus 2 times 1. Therefore, x is equal to 4. So basically, I have this scenario right here in some shape or form. It could be a vertically oriented ellipse. So here I see that when x is equal to 2, y was equal to, or what, where is it? 2. and when x is equal to 4, y was equal to 1, or vice versa. So our two solutions are 2, 2 and 4, 1. Let's take a look. So x squared plus 4y squared equals 20, and x plus 2y equals 6. Look up here, and that's pretty close to what I drew. Sort of close. So we have a solution here and here. All right, let's move on. I think we got time for one more. Yep, that's it. So this is already 20 minutes long, so let's see if we can get this under 30 minutes. All right, so here we actually have a circle. A circle with a center of 0, 2 and a radius of 2. Here we have a parabola, once again. So, as we showed in class, we got this situation, we got this situation, which I think we did a problem like that in class, where there's one solution. This has 4, and then, of course, we can get a solution that possibly has only 2 solutions. Anyway, those are some types of things to consider. Let's get to work. We see here that we can go in either direction. We can use substitution or we can use elimination. Since I showed you elimination in class, I'm going to do one like this one with elimination. Since we showed elimination in class, I'm going to show you substitution. So I'm going to take this equation and solve for x squared. So x squared is equal to 2y. Now I can take that and substitute it in for this x squared. So 2y plus y minus 2 squared equals 4. And multiplying the y minus 2 out, we get 2y plus y squared minus 4y plus 4 equals 0. I'm sorry, equals 4. Ah, messed up there. Therefore, adding like terms, we get y squared minus 2y plus 4 equals 4. And since this is a quadratic, set it equal to 0. So y squared minus 2y equals 0. And this will factor, take out the y, factor out the y, and that leaves us with y minus 2. Therefore, y is equal to 0, or y is equal to 2. And we're going to finish this up in a couple minutes. So if y is equal to 0, then x squared equals 2 times 0. So x squared is equal to 0. Therefore, x is equal to 0 with multiplicity 2. And if y is equal to 2, then x squared is equal to 2 times 2. So x squared equals 4, which means the absolute value of x is equal to 2. So x is equal to plus or minus 2. So we have a solution of 0, 0, and a solution, or two solutions, or two intersections, plus or minus 2, where are we at? 2. There we go. So we have 0, 0, and plus or minus 2, 2. So let's take a look at that. And we will be done. So x squared plus y minus 2 squared equals 4. And wait a minute, I messed up totally on that. Uh-oh. Where did I get? Oh, I know why. Oh, I put a minus. I didn't think I messed up. Should be a plus there. There we go. And x squared minus 2y equals 0. So here we go. So we have an intersection at -2, 2, an intersection at 2, 2, and an intersection of 0, 0, where it touches the graph. So that concludes this extra practice of solving nonlinear systems of equations. I hope you enjoyed it and learned something new. We will see you later. Bye-bye.